Hello friends, now we'll start the new chapter differentiation. Also, we called it as the derivative. Derivative हा 12वीच्या दृष्टिकोनातून आणि पुढच्या तुमच्या इंजिनिअरिंगच्या दृष्टिकोनातून अतिशय महत्त्वाचा चॅप्टर आहे. यापूर्वीच आपण लिमिट्स अँड कंटिन्युटी हा चॅप्टर संपवलेला होता आणि त्याच्यावरच डिपेंडिंग असणारा हा चॅप्टर आहे. मी सर्व एक्झाम्पल्स अतिशय सोप्या भाषेत सॉल्व केले. निश्चितच तुम्हाला ते आवडतील. नाउ लेट अस स्टार्ट. Derivatives of some standard functions. Now which are the some standard functions? The constant function, trigonometric functions, logarithmic function, exponential functions. These are the standard functions. Now first we'll find out the derivative of constant function. That is the ddx of k is equals to 0, where k belongs to the set of real number. The meaning of this is that the derivative of the constant. Now here variable is x, but to find the derivative with respect to x of any number which is other than x is always 0. Now we will prove this by using the definition of the derivative, that is the first principle. Now see this, f of x is equals to k. Here it is a constant function. F of x is equals to k and f of x plus h is also k. It's a constant function, and that's why by the definition of the first principle, f dash of x is equals to limit h tends to 0 f of x plus h minus f of x upon h, limit h tends to 0 f of x plus h minus f of x upon h, and we treat this as the f dash of x, that is the first derivative of the given function. Means what? F dash of x. If there is a 2 dash, then it is a second differentiation. If there is a 3 dash, then it is a third differentiation. Now this is the definition of the first principle, that is f dash of x is equals to limit h tends to 0 f of x plus h minus f of x upon h. Now we will substitute the values. Limit h tends to 0. आता इथे बघा, f of x plus h ची व्हॅल्यू आपल्याला काय दिली होती? k, आणि f of x ची व्हॅल्यू पण k च आहे, म्हणजे k minus k काय होतो? तर 0 होतो. Here the f of x plus h is k, f of x is also k, k minus k is 0, and 0 upon any number is 0, and hence the derivative of the constant is 0. Derivative of k is 0. But actually what is meant by the derivative of the constant is 0? जर समजा तुम्हाला डेरिव्हेटिव्ह phi चा डेरिव्हेटिव्ह काढायचा असेल with respect to x, the derivative of phi with respect to x is 0 because the phi is a constant. Derivative of 3 with respect to x is 0. Derivative of p with respect to x is also 0 because the p is other than x. Now see this. For example, derivative of minus 5 is 0, derivative of 5 by 2 is 0. Next, the derivative of the power function, that is a ddx of x raised to n. This is very important formula. The derivative of x raised to n is equals to n into x raised to n minus 1. याचा अर्थ काय की x raised to n, n हा कुठलाही नंबर असेल, and here I treated here n belongs to set of natural number, but here if we take, then we'll take the different types of the examples afterwards. If we take the n is equals to the real, that is the n belongs to set of real number, again we can find out the derivative of that functions also. But in this case, we are taking n belongs to set of natural number. Now see this here. That is f of x is equals to x raised to n. And what is f of x plus h? Is x plus h is equals to x plus h bracket raised to n. याचा अर्थ काय की जर समजा x ची व्हॅल्यू आपण इथे बदलली, x च्या जागी काय टाकला, x plus h बरोबर x plus h bracket raised to n. Now we'll see the definition of the first principle. Derivative find out करण्याची डेफिनेशन आहे आणि त्या डेफिनेशनला आपण काय करतो, डेरिव्हेटिव्ह ऑफ द फर्स्ट प्रिन्सिपल. परंतु त्याच्या आधी आपण x प्लस h ब्रॅकेट रेस टू n त्याचं एक्सपान्शन करणार आहोत आणि हे एक्सपान्शन कसं असणार आहे, बाय युजिंग द बायनॉमियल थिअरम. what of that the binomial theorem? X plus h bracket raised to n is equals to nc0 x raised to n nc1 x raised to n minus 1. म्हणजे पहिल्यांदा x ची पॉवर n असणार आहे आणि h ची किती होती 0 म्हणून h raised to 0 we treat it as 1. नंतर किती nc1 x ची पॉवर एकाने कमी केली आणि दुसरी एकाने वाढवतो. या प्रकारे आपल्याला असं मिळतं की nc1 x raised to n minus 1 into h nc2 x raised to n minus 2 into h square plus dash dash plus ncn x raised to आणि लास्ट टर्म काय असेल आपल्याला तर ncn x raised to 0 and h raised to n. Now next x raised to n nc1 x raised to n minus 1 या प्रकारे. Now see this here nc0 ची किंमत 1 असते आणि ncn ची पण किंमत किती असते, the value of nc0 and ncn is 1. Now value of the nc1 we treated is at 1, treated as it is because it is not necessary. And x raised to n minus 1 into h x raised nc2 we treated nc2 x raised to n minus 2 h square plus dash dash. And what about the last? The value of ncn is 1, x raised to 0 is also 1, and here is a h raised to n. Therefore we have the value of f of x plus h is equals to x raised to n plus nc1 x raised to n minus 1 into h plus nc2 x raised to n minus 2 h square plus dash dash plus h raised to n, and in this way. Now next we'll substitute the value of these in the definition of the first principle. Now see this definition. F dash of x is equals to limit h tends to 0 f of x plus h minus f of x upon h. Now here limit h tends to 0. Now substitute the value x raised to n plus nc1 x raised to n minus 1h plus nc2 x raised to n minus 2 into h square plus dash dash plus h square minus x raised to n upon h. Now here x raised to n plus and minus get cancel upon h. आता या सर्व टर्म्स मध्ये इथे h आहे, इथे h आहे, इथे h आहे. We'll take h as common. Now in all these steps there is h. We'll take h as a common and simplify it. Now see this. Now I will substitute here the values, and now see this here. That is x raised to n nc1 x raised to n minus 1 into h plus nc2 x raised to n minus 2 into h square plus dash dash plus h raised to n minus x raised to n upon h. Now here plus x raised to n and minus x raised to n get cancelled. Now take h as common from all these remaining terms, and if you take h as common then you will get like this. Now see this here h and h. If you take h as common then you will get nc1 x raised to n minus 1 nc2 x raised to n minus 2 into h plus dash dash plus h raised to n minus 1 upon h. This h get cancelled, and if we take the limit of this, then what will happen? That is, after the first term, every term has a h term, and therefore their limits become 0. Now this will become 0. This will all will become 0, and then what will remaining? nc1 x raised to n minus 1. But again, what is the value of nc1? NCR. The formula for the NCR is n factorial upon n minus r factorial into r factorial, and therefore we will write it is like this: n factorial upon n minus 1 factorial into 1 factorial, and that is equals to like this, x raised to n minus 1. Now this n factorial can be written as n into n minus 1 factorial upon n minus 1 factorial. Now n minus 1 factorial, n minus 1 factorial get cancelled. That is n into x raised to n minus 1. And in this way, we get the derivative. That is f of x is equals to x raised to n. Then f dash of x is equals to n into x raised to n minus 1. This is the derivative. Now we'll see the examples. For example, that is a x raised to y is equals to x raised to 5. मग याचा जर डेरिव्हेटिव्ह काढायचा असेल तर त्याची ही पॉवर पुढे घ्यायची आणि त्या 5 मधनं 1 मायनस करायचा. Therefore you will get the derivative, that is a 5 into x raised to 5 minus 1, that is a 5x raised to 4. Now see this here. Now second example, y is equals to x raised to minus 6 असं दिलं असेल तर त्याचा डेरिव्हेटिव्ह काढताना हा minus 6 पुढे घ्यायचा आणि त्या 6 मधनं x च्या पॉवरला काय करायचं? minus 6 minus 1. Then you will get x raised to minus 7. Now see this here. Therefore minus 6 into x raised to minus 7. Third, if y is equals to 1 upon x, then what will be its derivative? मग डेरिव्हेटिव्ह काढताना आपल्याला तो x कसा पाहिजे? तो न्यूमरेटरला असला पाहिजे. आपण जेव्हा हा x न्यूमरेटरला आणणार त्याची पॉवर किती होणार? मायनस होणार. अँड व्हॉट टेल्स द डेरिव्हेटिव्ह? मग हा मायनस 1 आधी पुढे घेणार आणि त्या x च्या पॉवर मधनं अजून एक मायनस 1 करणार. देन यू विल गेट मायनस x रेज टू minus 2. Now see this here. Therefore dy by dx is equals to minus x raised to minus 1 minus 1. That is a minus x raised to minus 2. Now next is y is equals to x raised to 5 by 2. Same formula. तर तो 5 by 2 पुढे घेणार आणि 5 by 2 मधनं 1 मायनस करणार. That is 5 by 2 into x raised to 5 by 2 minus 1. That is 5 by 2 into x raised to 3 by 2. हा त्याचा डेरिव्हेटिव्ह असणार आहे. Now next example, if y is equals to 1 upon root x, therefore y is equals to root x. But what is the root x? Root x means what? X raised to 1 upon 2. Root x म्हणजे काय? तर x raised to 1 upon 2. मग तोच 1 upon 2 आपण न्यूमरेटरला लिहिला तेव्हा त्याची पॉवर किती होणार? y is equals to x raised to minus 1 upon 2. मग आता डेरिव्हेटिव्ह काढणार आपण म्हणजे minus 1 upon 2 ही पॉवर पुढे घेणार आणि त्या minus 1 upon 2 मधनं 1 मायनस करणार म्हणजेच तुम्हाला किती मिळेल? minus 1 upon 2 x raised to minus 1 upon 2 minus 1 means what? x raised to minus 3 by 2. Now see this here. Therefore dy by dx is equals to this is minus 1 upon 2 x raised to minus 3 by 2. मग आपण ही पॉवर प्लस करून खाली लिहू शकतो डिनोमिनेटरला किंवा keep it as it is. Now see this here. This is the derivative. If y is equals to 1 upon x root x, y is equals to 1 upon x root x. But what is it? X root x, x ची पॉवर 1 आहे. आणि रूट एक्स किती हाफ आहे, दॅट इज एक्स रेस टू 3/2. पुन्हा तो 3/2 आपण न्यूमरेटरला नेणार आणि तो जर आपण न्यूमरेटरला नेला तर त्याची पॉवर किती होणार, एक्स रेस टू -3/2. आता तुम्हाला प्रत्येकदा हा खालीच असताना आपण वरती एव्हरी टाइम वी टेक द गिवन फंक्शन टू द न्यूमरेटर. अल्जेब्रिक फंक्शन जेव्हा केव्हा असेल, सिंगल टर्म असेल, तेव्हा ते आपण न्यूमरेटरला आणत असतो आणि मग त्याचा डेरिव्हेटिव्ह फाइंड आउट करत असतो. y इज इक्वल्स टू एक्स रेस टू -3/2. मग याचा पुन्हा डेरिव्हेटिव्ह करताना -3/2 into x raised to -3/2 -1. That is -3/2 into x raised to -3/2 -1 means what? X raised to -5/2. Now see this here. This is the derivative. आता या पार्टमध्ये, आधीच्या पार्टमध्ये आपण डेरिव्हेटिव्ह ऑफ द कॉन्स्टंट फंक्शन, डेरिव्हेटिव्ह ऑफ एक्स रेस्ड टू एन फाइंड आउट केला. आता इथून पुढे आपण ट्रिग्नोमेट्रिक फंक्शनचे डेरिव्हेटिव्ह फाइंड आउट करणार. हे तुम्हाला सर्वांना फार लक्षात ठेवावं लागणार. यू हॅव टू रिमेंबर ऑल दीज डेरिव्हेटिव्हज ऑफ द ट्रिग्नोमेट्रिक फंक्शन्स. नाव ddx ऑफ द sin x इज इक्वल्स टू द cos x. म्हणजे काय की sin x चा डेरिव्हेटिव्ह विथ रेस्पेक्ट टू x इज व्हेरी इम्पॉर्टंट. द डिफरन्शिएशन of the sin x with respect to x. What is called x? X is called the variable. The derivative of sin x with respect to x is cos x. Now see this. Let f of x is equals to sin x. Then what is f of x plus h? Sin of x plus h. Therefore what is f dash of x? F dash of x is equals to limit h tends to 0 f of x plus h minus f of x upon h. ही आहे डेफिनेशन, द डेफिनेशन ऑफ द फर्स्ट प्रिन्सिपल. आणि मग याच्यात आपण तिथे व्हॅल्यूज टाकणार. दॅट इज लिमिट h टेंड्स टू 0 sin of x plus h minus sin x upon h. Now here we will apply the formula for sin c minus sin d. Now what is the formula for the sin c minus sin d? The sin c minus sin d is equals to 2 times cos of c plus d upon 2 minus sin of c minus d upon 2. Now see this here. Two times cos of c plus d upon 2 and sin of c minus d upon 2. इकडे बघा आता x प्लस h हा आपण जर c ट्रीट केला आणि हा d ट्रीट केला, दॅट इज x प्लस h प्लस x अपॉन 2 इंटू साइन ऑफ c माइनस d. बट व्हाट इज c हियर? x प्लस h माइनस x अपॉन 2 and simplify now this, then you will get divided by h. आता हे simplification बघा. Now see this simplification. X plus x, it is become 2x. 2x plus h upon 2. Then you will get x plus h upon 2. या प्रकारे x plus x म्हणजे किती आला? 2x. That is x plus h upon 2. Sin plus x minus x get cancelled. Then you will get h upon 2. Sin of h upon 2 upon h. आता इथे आपण लिमिट घेणार याच्यामध्ये. Sin of h upon 2. What is our standard result? Limit theta tends to 0. Sin theta upon theta is 1. मग इथे आपल्याला ऍडजस्ट करता येतं का? Yes, we can adjust it. Sin of h upon 2 upon this h upon 2. पण इथे 2 नाही, तर आपण इथे 2 ऍडजस्ट करणार. Now see this here. That is the cos of x plus h upon 2 into sin of h upon 2 upon h upon 2. Now what is the limit of this? Sin of h upon 2 upon h upon 2 as h tends to 0. The limit of this is 1. Therefore, sin of h upon 2 upon h upon 2, the value of this limit is 1. And therefore, as h tends to 0, you will get cos of x into 1. And therefore, the f dash of x is equals to cos x. and hence the derivative of sine of x is cos x. See this? If f of x is equals to sine x, then f dash of x is equals to cos x. Therefore, ddx of sine of x is equals to cos x. Now, this ddx is called the operator. Next is number 2. The derivative of cos of x is minus sine of x. पुन्हा आपण by first principle we will prove that the derivative of cos of x is minus sine of x. Now see this again. Let f of x is equals to cos x. Then what is the f of x plus h? That is, x is replaced by h. Therefore, you will get f of x plus h is equals to cos of x plus h. Now again here we will apply the definition of the first principle. First principle ची definition काय? F dash of x is equals to limit h tends to 0 f of x plus h minus f of x upon h, and that's why substitute the value. Limit h tends to 0 f of cos of x plus h minus cos of x upon h, and simplify this. That is, cos c minus cos t is equals to. Now here we have the formulas of cos c minus cos t. Cos c minus cos t, we can apply the two types. That is, minus 2 times cos of c plus t upon 2 into sine of c minus d upon 2. Now see this here. Minus 2 times sine of c plus d upon 2 minus 2 times sine of, this is a c and this is a d, c plus d upon 2 into cos of into sine of c minus d upon 2. I will change it. That is a minus 2 times sine of c plus d upon 2 into sine of c minus d upon 2. Now what will happen in this case? X plus h is 2x plus h upon 2. Then after simplification you will get x plus h upon 2. And now what will happen here? Plus x minus x get cancelled and you will get h upon 2. Limit h tends to 0. This is the simplification. What about here? Minus 2 times sine of x plus h upon 2 into sine of h upon 2 upon h. आता इथे साइन ऑफ h अपॉन 2 आहे. आपल्याला तोच अँगल खाली पाहिजे असतो, म्हणजेच h अपॉन 2 पाहिजे. मग तो 2 कुठने घेणार? तर तो 2 हा घेणार. दिस 2 कॅन बी रिटन एज h अपॉन 2. नाउ सी दिस हियर. h upon 2 upon h upon 2. Now the value of this limit, as h tends to 0, sine of h upon 2 is 1. And what about here? Minus sine of x. Therefore, minus sine x into 1. And hence, the derivative of cos of x is minus sine of x. Now, see this here. If that is f dash of x is equals to minus sine x, therefore ddx of cos of x is minus sine x. Now third. Now next is derivative of tan of x. The derivative of tan of x is a sec square x. Now we will find out the derivative of tan of x by using the first principle. Again, f of x is equals to tan of x. Then what is f of x plus h? Is equals to tan of x plus h. And therefore, the definition of the first principle, f dash of x is equals to f of x plus h minus f of x upon h. Now here is Limit h tends to 0, tan of x plus h minus tan of x upon h. Now this tan of x plus h can be written as sine of x plus h upon cos of x plus h minus sine of x upon cos of x. Now see this here. Now we'll make here cross multiplication. That is a sine of x plus h into cos of x minus sine of x into cos of x plus h. Upon this h into cos of x plus h into cos of x. Therefore, as limit h tends to 0, now this is expansion of sine of a minus b. Now here, what is a? A is sine of x plus h. A is x plus h and b is x. Therefore, sine of x plus h minus sine x. Sine of x plus h minus sine x upon h into cos of x into cos of x plus h. Now here plus x minus x will get cancelled. And then you will get sine of h upon h. As h tends to 0, sine of h upon h is 1, and again 1 upon cos x into cos of x. That is cos x into cos x is cos square x. And what is the reciprocal of 1 upon cos square x? Is sec square x. That is 1 upon cos square x means what? The sec square x. See this here. This is important. Sine of x upon h into 1 upon cos of x into cos of x plus h. Now as h tends to 0, the value of this limit is 1 into 1 upon cos x into cos x. That is the cos square x. And 1 upon cos square x is 1 upon cos square x. Cos square x means what? The sec square x. Therefore, you will get the derivative of tan of x is a sec square x. Now the derivative of cot of x. The derivative of cot of x is minus cosec square x. Now we'll find out by using the definition of the first principle. Now here again the cot of x is equals f of x is equals to cot of x. Now what is f of x plus h? That is the cot of x plus h. Therefore f dash of x is equals to limit h tends to 0. Again the definition of the first principle, f dash of x is equals to limit h tends to 0, f of x plus h minus f of x upon h. Now substitute the values. These are the values. That is the cot of x plus h minus cot of x upon h. But what is the cot? Cot means what? Cos of x plus h upon sine of x plus h minus cos of x upon sine of x. Next the cross multiplication. The whole divided by h. Now make here cross multiplication. After the cross multiplication, you will get sine of x into cos of x plus h minus cos x into sine of x plus h. Now here, if you make the cross multiplication, then you will get like this. That is a sine of x cos of x plus h minus sine of x plus h into cos of x upon h into sine of x plus h into sine x. Now this is the expansion of sine of a minus b. What is here a? A is x and b is x plus h. Now see this here. Limit h tends to 0, sine of x minus in bracket x plus h upon h into sin x plus h. Now if we open the bracket, now plus x and minus x get cancelled. Then you will get sine of minus h. But what is the sine of minus theta? Sine of minus theta is minus sine theta. These are the normal steps. Plus x minus x get cancelled. Sine of minus h upon h into sine of x plus h into sine x. Therefore, what is the sine of minus theta is minus sine theta. Therefore, we write here the minus sign. The sine of h upon h. Sine of minus theta is minus sine theta, and here we had written. Therefore, sine of h upon h, the value of this limit will be the 1. Now, see this again. That is a 1 upon sine of x plus h into sine x. As h tends to 0, the sine x into sine x, then it will become sine square x. And what is the answer? 1 upon sine square x. It is a cosec square x. Therefore, derivative will be the minus cosec square x. Now, see this here. This is limit minus 1. This is 1, but here is minus 1 into 1 upon sine x into sine x. That is sine square x. 1 upon sine square x means what? Cosec square x minus cosec square x. Therefore, if f of x is equals to cot x, then f dash of x is equals to minus cosec square x. Fifth is ddx of sec x. What is the derivative of sec x? Sec x into tan x. Again, that y is equals to sec x is equals to f of x. What is the f of x plus h? Sec of x plus h. Therefore, f dash of x is equals to limit h tends to 0, f of x plus h minus f of x upon h. This is the definition of the first principle. Limit h tends to 0, sec of x plus h minus sec of x upon h. Now, to simplify this, sec of x plus h means what? 1 upon cos of x plus h, and then we will multiply the cross multiplication. Now make the cross multiplication. Limit h tends to 0, cos of x into cos of x plus h upon h into cos of x plus h into cos x. Now here we will apply the formula for cos c minus cos b. Cos c minus cos b, in this case, that is a minus 2 times sine of c plus d upon 2 into sine of c minus d upon 2. Now see this here. That is it. 2 times. Also we will apply for this type of the formula. Now here I am applying the formula, that is a 2 times sine of c plus d upon 2 and sine of d minus c upon 2. It is a d minus c upon 2. Now here plus x and minus x cancel. You will get sine of h upon 2, and here is h. Again, this 2 will take for that simplification. What about here? X plus x means what? 2x plus h upon 2. If we simplify this, then you will get x plus h upon 2. That is limit h tends to 0, 2 sine of x plus. This is a simplification. Now see this. That is a 2 times sine of x plus x, 2x upon 2. That is x plus h upon 2. Sine of plus x minus h get cancelled, h upon 2 upon this h, and cos of x plus h into cos x. Therefore, their simplification, that is a sine of h upon 2. This 2 is adjusted here into 1 upon cos of x plus h into cos x and simplify this. Therefore, as h tends to 0, that is sin x into 1 upon cos x into cos x. That is sin x upon cos x is a tan x into 1 upon cos x. But 1 upon cos x means what? Sec x. And that's why tan x into sec x. Therefore, the derivative of sec x is sec x into tan x. Therefore, if f of x is equals to sec x, then f dash of x is equals to tan x into sec x. Therefore, dy by dx is equals to tan x into sec x. Now the next is d dx of cosec x is equals to minus cosec x into cot x. Means what? The derivative of cosec x is minus cosec x into cot x. Now the derivative of cosec x is equals to minus cosec x into cot x. Now again we will solve this by simplify this or prove by using the first principle. Y is equals to f of x is equals to cosec x. Now what is the value of f of x plus h? That is x is replaced by x plus h. Therefore f dash of x is equals to limit h tends to 0. See this, f dash of x is equals to limit h tends to 0. F of x plus h minus f of x upon h. Limit h tends to 0. Cosec x plus h minus cosec x upon h. Now again the simplification. Cosec means what? 1 upon sine of x plus h minus 1 upon sine of x whole divided by h. Now make the cross multiplication. That is limit h tends to 0. Sine of x minus sine of x plus h upon h into sine of x plus h into sine x. Now here we apply the formula for the sine c minus sine d. Sine c minus sine d is equals to 2 times cos of c plus d upon 2 into sine of c minus d upon 2. Therefore, here that is x plus h is a 2x plus h upon 2. Therefore, 2 times cos of x plus h upon 2 into. Now here if we open the bracket, then plus x minus x will get cancelled. Then you will get minus sine of h upon 2 upon h. Now what is the sine of minus theta? Is minus sine theta. Therefore, we have written here minus sine. That is the 2 times upon their multiplication. I forget to write here. That is the sine x, sine of x plus h into sine x. Next to the denominator. These are the remaining terms. See this here. What is the limit of this? The limit of this will be 1. Here we will adjust the 2. That is, this 2 is adjusted here. That is divided by h upon 2. Sine of h upon 2 upon h upon 2. The value of this limit is 1. Now as h tends to 0, here is the cos x upon sine x. Means what? Cot x. And again 1 upon sine of x plus h means you will get sine of x. And 1 upon sine x means what? It is a cosec x. Therefore, that is the cos of x upon sin x into sin x, and the value of this limit is 1. Therefore, minus cot x into cosec x. Therefore, the derivative of cosec x is minus cosec x into cot x. Now, the derivative of exponential functions. What about the derivative of exponential functions? Means the derivative of e raised to x and a raised to x. Now the ddx of a raised to x is equals to a raised to x into log of a, where a is positive. Y is equals to f of x. Therefore, is equals to a raised to x. Then dy by dx is equals to f dash of x is equals to a raised to x into log of a. Now we'll show by using the first principle. Y is equals to f of x is equals to a raised to x. Then what is f of x plus h is equals to a raised to x plus h. Therefore, f dash of x is equals to dy by dx is equals to limit h tends to 0 f of x plus h minus f of x upon h. Therefore, limit h tends to 0 a raised to x plus h minus a raised to x upon h. Now here we'll take a raised to x common from these two terms. Therefore, you will get a raised to x in bracket a raised to h minus 1 upon h. Now again this can be written a raised to x, limit h tends to 0, a raised to h minus 1. Therefore, a raised to x. And what about the limit of this? The limit as h tends to 0, a raised to h minus 1 upon h. This limit is nothing but the log of a that we have learned in the chapter limit. This is the log of a, and hence the derivative of a raised to x is a raised to x into log of a. Therefore, f dash of x is equals to ddx of a raised to x is equals to a raised to x into log of a. Now the derivative of e raised to x is equals to e raised to x. Now y is equals to e raised to x. F of x is equals to e raised to x. What is f of x plus h is equals to e raised to x plus h. Therefore, again the definition of the first principle, f dash of x is equals to dy by dx is equals to limit h tends to 0 f of x plus h minus f of x upon h. E raised to x plus h minus e raised to x upon h. Take e raised to x as a common, then in bracket you will get e raised to h minus 1 upon h. Now what is happening here? Here is a e raised to x is constant because as h tends to 0, we write here e raised to x into limit h tends to 0, e raised to h minus 1 upon h. Now, from the limit chapter, the value of this limit is 1. That is equals to e raised to x into 1. Therefore, the derivative of e raised to x is equals to e raised to x. Therefore, ddx of e raised to x is equals to e raised to x. Now, next function is y is equals to log of x. Therefore, f of x is equals to log of x. Therefore, what is f of x plus h? Is log of x plus h. Therefore, f dash of x is equals to limit h tends to 0 f of x plus h minus f of x upon h. Therefore, limit h tends to 0 log of x plus h minus log of x upon h. And simplify this as limit h tends to 0 1 upon h. Therefore, limit h tends to 0 log of 1 plus h upon x raised to 1 upon h, or we'll write this like this, log of limit h tends to 0 log of 1 plus h upon x upon h upon x. That is, here we adjust h. Now what is the value of this limit? The value of this limit is 1. That is 1 into 1 upon x. That is equals to 1 upon x. Now see this here. Limit h tends to 0, log of into 1 upon x. That is 1 into 1 upon x, and that is equals to 1 upon x. F dash of x is equals to 1 upon x. Therefore, the ddx of log of x is 1. Now, find the derivative of the following with respect to x. The first is f of x is equals to x square plus 3x minus 1. Then what about f of x plus h? Now in this case, x is replaced by x plus h. F of x plus h is equals to x plus h bracket square plus 3 in bracket x plus h minus 1. Now we will apply here the expansion. F of x plus h is equals to x plus h bracket square plus 3 in bracket x plus h minus 1. Therefore, x square plus 2xh plus h square. 3x plus 3h minus 1. Therefore, after simplification, that is f of x plus h minus f of x is equals to, we will simplify here, x square plus 2xh plus h square plus 3x plus 3h minus 1 minus in bracket x square plus 3x minus 1. Therefore, after simplification, x square plus 2xh plus h square plus 3x plus 3h minus 1 minus x square minus 3h plus 1 plus x square minus x square get cancelled, plus 3x minus 3x get cancelled, plus 1 minus 1 get cancelled. Then you will get 2xh plus h square plus 3h. Therefore, f of x plus h minus f of x is equals to 2xh plus h square plus 3h. Limit h tends to 0. 2x h plus h square plus 3h upon h. And limit h tends to 0. Take h as common. Then in bracket you will get 2x plus h plus 3 upon h. Now here again h get cancelled. Now as h tends to 0, therefore you will get 2x plus 3, and that is equals to 2x plus 3. Now sine of 3x is equals to, now the function is sine of 3x, f of x is equals to sine of 3x, f of x plus h, there must be f of x plus h, is equals to, now you can see this, that is a sine 3 in bracket x plus h. If we simplify, then you will get sine of 3x plus 3h. Now again, f of x plus h minus f of x is equals to sine of 3x plus 3h minus sine of 3x. Now here we will apply the formula for sine c minus sine d. That is equals to 2 times cos of c plus d upon 2. Means what? 3x plus 3h plus 3x upon 2 into sine of c minus d upon 2. That is the 2 times cos of c plus d upon 2 sine of c minus d upon 2. And if we see this here, 3x plus 3x is a 6x plus 3h upon 2, and plus 3x minus 3x get cancelled. That is a sine of 3h upon 2. Therefore, by definition of the first principle, f dash of x is equals to limit h tends to 0, f of x plus h minus f of x upon h. H tends to 0. Now we will substitute that values. That is the 2 times cos of 6x plus 3h upon 2 and sine of 3h upon 2 upon h. Therefore, limit h tends to 0, 2 times cos of 3x plus 3h upon 2 sine of 3h upon 2 upon, we'll adjust here 3h upon 2, that is a 3. Therefore, as h tends to 0, sine of 3h upon 2 upon 3h upon 2, the value of this limit is 1. 1 into 3, that is a 3. And as h tends to 0, this 3h upon 2 becomes 0. Therefore, you will get cos of 3x. Cos of 3x into 1 into 3. And hence, 3 times cos of 3x. Therefore, the derivative of sine of 3x is 3 cos of 3x. Now see, e raised to 2x plus 1. Again, f of x is equals to e raised to 2x plus 1. Therefore, what is f of x plus h? Now here f of x plus h is equals to 2 e raised to 2 in bracket x plus h plus 1. Now here again we apply the formula for the f dash of x is equals to limit h tends to 0, f of x plus h minus f of x upon h. Limit h tends to 0, e raised to 2 in bracket x plus h plus 1 minus e raised to 2x plus 1. Now from these two, we will take e raised to 2x plus 1 as a common. Limit h tends to 0, e raised to 2x plus 2h. This is the simplification. 2x plus 2h plus 1 minus e raised to 2x plus 1 upon h. Therefore, e raised to 2x plus 1. Now this is written as in this manner, e raised to 2x plus 1 separately dot e raised to 2h minus e raised to 2x plus 1. Now take e raised to 2x plus 1 as a common. Limit h tends to 0, e raised to 2h minus 1. E raised to 2h minus 1 upon h. Now here is e raised to 2h upon 2. Therefore, limit h tends to e raised to 2h minus 1 upon 2h into 2. Here not h, but we'll adjust here 2. That is a 2. Now see this here, e raised to 2x plus 1 as it is. Limit h tends to 0, e raised to 2h minus 1 upon 2h. The value of this limit is 1 into 2. Therefore, 2 times e raised to 2x plus 1. This is the derivative. Therefore, if the function f dash of, that is 2 e raised to 2x plus 1, that was the derivative. Now that is e raised to 3x. Now what is the derivative of e raised to, 3 raised to x? What is the derivative of 3 raised to x? The derivative of 3 raised to x is 3 raised to x into log of 3. Now we'll solve this by using the first principle. Y is equals to f of x is equals to 3 raised to x. F dash of x is equals to limit h tends to 0, f of x plus h minus f of x upon h. Substitute the values. Limit h tends to 0, 3 raised to x plus h minus 3 raised to x. Therefore, upon h, limit h tends to 0. Take 3 raised to x as a common, then you will get 3 raised to h minus 1 upon h. Therefore, h tends to 0. Therefore, 3 raised to x into limit h tends to 0, 3 raised to h minus 1 upon h. That is equals to 3 raised to x into, what is the limit of this? Limit h tends to 0, 3 raised to h minus 1 upon h. That is a log of 3. Therefore, dy by dx is equals to 3 raised to x into log of 3. Log of 2x plus 5. Log of 2x plus 5, y is equals to f of x is equals to log of 2x plus 5. Therefore, f dash of x is equals to dy by dx is equals to limit h tends to 0, f of x plus h minus f of x upon h. And that's why we'll substitute the values. Limit h tends to 0, log of 2 in bracket x plus h plus 5 minus log of 2x plus 5 upon h. Therefore, limit h tends to 0, log of 2x plus 5 plus 2h minus log of 2x plus 5 upon h. That is, limit h tends to 0, log of 2x plus 5 plus 2h upon 2x plus 5 upon h. And now again this can be written as, that is, the limit h tends to 0, log of 2x plus 5. These two terms get cancelled. That is, you will get 1 plus 2h upon 2x plus 5 upon h. Now what is our basic formula? That is a log of limit x tends to 0, log of 1 plus x upon x is 1. But here is a log of 1 plus 2h upon 2x plus 5 upon 2h upon 2x plus 5. But here only we have h. Therefore, we will adjust here 2 upon 2x plus 5. Therefore, that is here limit h tends to 0. Basically, we have only the h here. This is h. But what is the next terms? That is 2 upon 2x plus 5. To balance these two, we have here is a 2. To balance this 2x plus 5, this is divided by 2x plus 5. Now the value of this whole limit is 1. That is the standard formula is log of 1 plus x upon x. In that form, the value of this limit is 1. And you will get 2 upon 2x plus 5. Now see this here. Therefore, dy by dx is equals to f dash of x is equals to 2 upon 2x plus 5. Therefore, y is equals to log of 2x plus 5. Then its a derivative is 2 upon 2x plus 5. Now next is f is y is equals to f of x is equals to tan of 2x plus 5, 2x plus 3. Then what is f of x? That is tan of 2x plus 3. Therefore, what is f of x plus h? F of x plus h is equals to tan of 2 in bracket x plus h plus 3. That is a tan of f dash of x is equals to dy by dx is equals to limit h tends to 0, f of x plus h minus f of x upon h. That is a tan of 2x plus h plus 3 minus tan of 2x plus 3 upon h. Limit h tends to 0, tan of 2x plus 3. This is a simplification, tan of 2x plus 3 upon h. Now again, what is meant by the tan? Tan means sine of x upon cos of x. In the same way, that is the tan of 2x plus 3 plus 2h upon cos of 2x plus 3 plus 2h minus sine of 2x plus 3 cos of 2x plus 3. Now here we make the cross multiplication. That is limit h tends to 0, sine of 2x plus 3 plus 2h into cos of 2x plus 3 minus cos of 2x plus 3 plus cos. This is the multiplication. And now this whole divided by h into cos of 2x plus 3 plus 2h into cos of 2x plus 3. Now this is the expansion of sine of a minus b. What is here a? A is a 2x plus 3 plus 2h and b is a 2x plus 3. Now see this here. Limit h tends to 0, sine of 2x plus 3 plus 2h minus 2x plus 3 upon h in bracket cos of 2x plus 3 plus 2h cos of 2x plus 3. And now see this 2x plus 3, this 2x plus 3 get cancelled. You will get 2h sine of 2h. That is the limit h tends to 0, sine of 2h upon h into 1 upon cos of 2x plus 3 plus 2h into cos of 2x plus 3. Now adjust here 2. That is the sine of 2h upon 2h. The limit of this is 1. And therefore one thing is still remaining, that is we have to adjust 2 there. Adjusted here, that is a 2. The limit of this is 1. As h tends to 0, this 2h becomes 0. Then you will get cos of 2x plus 3 into cos of 2x plus 3. It will become cos square 2x plus 3. And this reciprocal is a 2 sec square 2x plus 3. And therefore dy by dx is equals to 2. Now y is equals to sec of phi x minus 2. Therefore f of x plus h is equals to sec of phi in bracket x plus h minus 2. Therefore f dash of x is equals to dy by dx is equals to limit h tends to 0 f of x plus h minus f of x upon h. Limit h tends to 0 sec of phi x plus phi h minus 2 upon minus sec of phi x minus 2 upon h. Now limit h tends to 0 1 upon cos of phi x minus 2 plus phi h minus 1 upon cos of phi x minus 2 minus 1 upon cos of phi x minus 2 upon h. Now again make here cross multiplication. That is, after making the cross multiplication, you will get these terms. Now see this here. This is the cross multiplication, that is a cos of phi x minus 2 minus cos of phi x minus 2 plus phi h upon h into cos of phi x minus 2 plus phi h dot cos of phi x minus 2. Now this is a cos c minus cos d, that is, we'll apply the formula. That is minus 2 times sine of c plus d upon 2 and sine of c minus d upon 2. This is the formula that we are applying here. Sine of c plus d upon 2. This is a c, this is d, in sine of c minus d upon 2. Therefore, that is the limit h tends to 0 minus 2 sine of 2 times phi x minus 2 upon 2 plus phi h upon 2 sine of minus phi h upon 2 upon h cos of phi x minus 2 plus phi h into cos of phi x minus 2. Limit h tends to 0 minus 2 sine of phi x minus 2 plus phi h upon 2 into minus phi h upon 2. Now see this here, here is a minus sign again here, but what is the sign of minus theta? It is minus sin theta. Therefore this minus sign and this minus will become plus now in the next step. These are the total expressions. Limit h tends to 0. Now I had written there till minus sign minus 1. Here is a minus sine of phi h upon 2. And now in the next step I will make their sign as a plus. Limit h tends to 0 plus 2 sine of phi x minus 2 plus phi h upon 2 into sine of phi h upon 2 upon phi h upon 2 into phi. Now here we are adjusting only the phi. Also we can adjust 2 also. If we adjust here 2, no problem. That is, this is a 2, here is a 2 adjusted, phi is adjusted. But now these 2 and these 2 will get cancelled in the next step. That is a 2 times sine of phi x minus 2 Now what's happening here? Sine of phi h upon 2 sine of phi divided by 2. This is the value of this limit is 1. Now as h tends to 0, this becomes 0, this becomes 0. Then you will get, that is a 2 sine of phi x minus 2 upon cos of phi x minus 2 into cos of phi x minus 2. That is a 5 sine of phi x minus 2 upon cos of phi x minus 2 into 1 upon cos of phi x minus 2. Then that is a 5 tan of phi x minus 2 into sec of phi x minus 2, and this is the derivative. That is a sec of phi x minus 2. Easy. Then it's a dy by dx is equals to 5 tan of phi x minus 2 into sec of phi x minus 2. You can see in the derivative. This is the derivative. Now in the next step, x root x. X root x means what? The power of this x is 1 and this is a half, means what? X raised to 3 by 2. Now f of x plus h is equals to x plus h bracket raised to 3 by 2. Now again we'll apply the definition of the first principle, that is f dash of x is equals to limit x tends to 0 f of x plus h minus f of x upon h. That is limit h tends to 0 x plus h bracket raised to 3 by 2 minus x raised to 3 by 2 upon h, and that's why you will get limit h tends to 0 x plus h bracket raised to 3 by 2 minus x raised to 3 by 2 upon h. Now to simplify this, we will apply to the numerator and the denominator the rationalizing factor. What is the rationalizing factor? X plus h bracket raised to 3 by 2 plus x raised to 3 by 2 upon x plus h bracket raised to 3 by 2 plus x raised to 3 by 2, and that's why limit h tends to 0 x plus h bracket raised to 3 by 2, and it's a square. This is a minus b into a plus b, then you will get a square minus b square, means what? X plus h bracket raised to 3 by 2 bracket square minus x raised to 3 by 2 bracket square upon h into x plus h bracket raised to 3 by 2 plus x plus x raised to 3 by 2, that is x plus h bracket cube minus x cube. Now expand this, x plus h bracket cube. Now after the expansion, that is x cube plus 3x square h plus 3 xh square plus h cube minus x cube. That is h in bracket x plus h bracket raised to 3 by 2 plus x raised to 3 by 2. Now take h as common, then you will get 3x square plus 3xh plus h square upon h in bracket x plus h bracket raised to 3 by 2 plus x raised to 3 by 2. Now this h get cancelled, and we will take now the limit of this, that as h tends to 0, this term will become 0, this will become 0, this h will become 0. Then what you will get? 3x square. Here is x raised to 3 by 2, x raised to 3 by 2. That is a 2 times x raised to 3 by 2. That is a 3x square upon 2 times x raised to 3 by 2. Therefore 3 by 2 into x raised to 1 upon 2. Therefore it's a derivative. That the of x is equals to x raised to 3 by 2, then its derivative is 3 by 2 into x raised to 1 upon 2. Now next, find the derivatives with respect to the first principle, that is a root of 2x plus 5 at x is equals to 2. Now by the definition we will find out the first derivative and then replace x is equals to 2. That is the proper way. Therefore, I had solved all these type of the examples in this. That is a f of x. This is the f of x is equals to root of 2x plus 5. F of x plus h is equals to in root of 2 in bracket x plus h plus 5. F dash of x is equals to limit h tends to 0 f of x plus h minus f of x upon h. That is h tends to 0 in root of 2 in bracket x plus h plus 5 minus root of 2x plus 5 upon h. Therefore, now simplify this. Multiply the numerator and the denominator by the rationalizing factor of. This is we are multiplying here. Now see this, I will explain now. See this. That is the multiplied n and d by in root of 2x plus 5 plus 2h plus in root of 2x plus 5 upon in root of 2x plus 5 plus 2h plus in root of 2x plus 5. Then what will get this? The radical sign will get cancelled and you will get limit h tends to 0 2x plus 2h plus 5 minus 2x plus 5 and this is the term. These roots are get cancelled. 2x plus 2h plus 5 minus in bracket 2x plus 5 upon h into in square root of 2x plus 5 plus 2h plus root of 2x plus 5. Now simplify this. Therefore, after the cancellations, this is the 2x plus 2x minus 2x get cancelled, plus 5 minus 5 will get cancelled. Limit h tends to 0, 2h upon h in bracket in under root of 2x plus 5 plus 2h plus in root of 2x plus 5. Limit h tends to 0, in root of 2x plus 5 plus 2h in root of 2x plus 5 as h tends to 0. Therefore, in root of 2x plus 5 plus in root of 2x plus 5 that is equals to 2 times 1 upon 2 times in root of 2x plus 5. This is the derivative. F dash of 2. Now here replace x by 2. That is a f dash of 2 is equals to 1 upon 2 in root of 2 into 2 plus 5. That is a simplification. This is a normal simplification. That is equals to this 2 to get cancelled. In the previous step, I had not cancelled it. Now see this here. That is equals to 1 upon 3. This is the answer. Therefore, f of 2 is equals to 1 upon 3. Now next. B, that is a tan of x at x is equals to pi by 4. Now we have solved this type in the previous example. You can see that is f of x is equals to tan of x, and then what is its derivative? F dash of x is equals to sec square. In the previous example we have solved this. You can see that. Therefore, f dash of pi by 4 is a sec of pi by 4, and that is equals to root 2 and bracket square. That is equals to 2. Therefore, f dash of pi by 4 is 2. Now see, that is f of x is equals to 2 raised to 3x plus 1 at x is equals to 2. Therefore, f of x is equals to 2 raised to 3x plus 1. F of x plus h is equals to 2 raised to 3 in bracket x plus h plus 1. F dash of x is equals to limit h tends to 0. F of x plus h minus f of x upon h. Now simplify this. F of 3x plus 1 plus 3h minus 2 raised to 3x plus 1 upon h. Now limit h tends to 0. 2 raised to 3x plus 1 in bracket 2 raised to 3h minus 1 upon h. That is limit h tends to 0. 2 raised to 3x plus 1. Therefore, 2 raised to 3h minus 1 upon 3h into 3. Therefore, the value of this limit is a log of 2 into 3. That is 2 raised to 3x plus 1 into log of 2 into 3. This is the answer. F dash of x is equals to 2 raised to 3x plus 1 log of 2 into 3. Therefore, f of 2 is equals to 2 raised to 6 plus 1, that is 7 log of 2 into 3. Therefore, 2 raised to 7 into 3 into log of 2. Therefore, f dash of 2 is equals to 2 raised to 7 3 log of 2 . That is 128 into 3 into log of 2. Again 128 into 3 means what? 384 log of 2. And this is the final answer. F dash of 2 is equals to 384 into log of 2. Now next is log of 2x plus 1 at x is equals to 2. Now again f of x is equals to log of 2x plus 1. F of x plus h is equals to log of 2 in bracket x plus h plus 1, and f dash of x is equals to limit h tends to 0 f of x plus h minus f of x upon h. Limit h tends to 0 log of 2 in bracket x plus h. Yes, important. And now simplify this. That is limit h tends to 0 log of 2x plus 1. This is simplification. 2x 2h plus 1. 2x plus 1 plus 2h minus log of 2x plus 1. Therefore, limit h tends to 0 log of 2x plus 1 plus 2h upon 2x plus 1. And their simplification. Limit h tends to 0 log of 1 plus 2h upon 2x plus 1 upon h. Limit h tends to 0 log of in bracket 1 plus 2h upon 2x plus 1 upon 2h upon 2x plus 1. That is 2 upon 2x plus 1. The value of this limit is again 1. That is 1 into 2 upon 2x plus 1. Therefore, 1 plus 2 upon 2x plus 1, as this is the formula. That is 2 upon 2x plus 1. So now the answer is not totally clear there. Therefore, f dash of x is equals to, that is 2 upon 2x plus 1. Therefore, the value of f dash of 2, that is equals to 2 upon 2 into 2 plus 1, and that is equals to 2 upon 5. 2 into 2, 4 plus 1. And this is the answer. Now next, e raised to 3x minus 4 at x is equals to 2. Therefore, f of x is equals to e raised to 3x minus 4. F of x plus h is equals to e raised to 3 in bracket x plus h minus 4. Therefore, f dash of x is equals to limit h tends to 0 f of x plus h minus f of x upon h. Limit h tends to 0 e raised to 3 in bracket x plus h minus 4 up minus e raised to 3x minus 4 upon h. Now, the simplification is limit h tends to 0 e raised to 3x plus 3h minus 4 minus e raised to 3x minus 4. Now we'll take the e raised to 3x minus 4 as a common. Limit h tends to 0. E raised to 3x minus 4 take as a common. Then in bracket you will get e raised to 3h minus 1 upon h. Now here we'll adjust the h, that is a 3h. 3x minus 4 upon the value of this limit is 1, that is a that is a 3 into e raised to 3x minus 4 f dash of x. Therefore, what is the f dash of 2? That is a 2 into e raised to 3 into 2, that is a 6 minus 4, that is e raised to 2. That is the f dash of 2 is equals to 3 to e raised to 2. This is the answer. Now next is that is f of x is equals to cos of x, and now in the starting we have find out the derivative of cos of x by using the first principle. Therefore I am writing here its answer, that is f dash of x is equals to limit h tends to 0 f of x plus h minus f of x upon h. Limit h tends to 0 cos of x plus h minus cos of x upon h. F dash of x is equals to minus. That is f dash of x is equals to minus sin x. Therefore, f dash of 5 pi by 4 is equals to f dash of 5 pi by 4 is equals to minus sine of 5 pi by 4. Now sine of 5 pi by 4 can be written as sine pi plus pi by 4, and sine of pi plus pi by 4, whenever there is a pi angle the function remains as it is. म्हणजे sine हा sinच राहत असतो minus sine of pi by 4, and the value of sine of pi by 4 is minus 1 upon root 2, and therefore we write here minus sine of pi plus pi by 4. That is the minus sine of pi by 4. Sine of pi by 4 is minus will become plus, and sine of pi by 4 is 1 upon root 2. And next is f dash of 5 pi by 4 is equals to 1 upon root 2. Now the question number 3. Show that the function f is not differentiable at x is equals to minus 3, where f of x is equals to x square plus 3. Now this is very important. F of x is equals to x square plus 3 for the values of x less than minus 3, and f of x is equals to 2 minus 3x for the values of x greater than or equal to minus 3. As it is not differentiable, means what? The given function is not continuous. Now see this here. F of x is equals to 2 minus 3x for x is greater than or equal to minus 3. Now we'll find out the value of f of minus 3. That is equals to 11. Replace x is equals to 11. आता तुम्ही म्हणाल की हाच फंक्शन इथे का घेतला व्हॅल्यू साठी, कारण की इथे लेस दॅन ऑर इक्वल टू. Now you will say that why you have taken this function, because here is a x is a greater than or equal to. It means that you can take the value of x is equals to 3. Therefore f of minus 3 is equals to 2 minus 3 in bracket minus 3. Therefore minus minus will become plus, that is a 9 plus 2, that is equals to 11. Therefore now we'll find out its left hand side limit, that is the limit h tends to 0 f of minus 3 plus h minus f of minus 3 upon h. That is the left hand side limit. For the left hand side limit we take the function, that is a x square plus 2. This is the function. And the value of f of minus 3 is minus 11. Therefore, as limit h tends to 0, in square bracket minus 3 plus h bracket square plus 3 minus 11 upon h. We'll substitute the values. Then we are taking the function x square plus 2. By mistake I had written it is a 3, but it is not 3. Don't take this as this is a 2. Therefore, after simplification, you will get, now I will show you again. That is a minus 3 plus h bracket square, expand it. That is a 9 minus 6h plus h square plus 2 minus 11. Therefore, you will get, that is a 9 plus 2. That is 11 plus 11 minus 11 get cancelled. That is h square minus 6h upon h. H get cancelled. As h tends to 0, you will get the limit is as a minus 6. This is the left hand side limit. And the right hand side limit, that is the limit h tends to 0, minus 3 plus h minus f of minus 3. For that we take the function 2 minus 3x. That is 2 minus 3x. That is a 2 minus 3x. What is x here? Minus 3 plus h minus f of minus 3. Its value is a minus 11. And after simplification, you will get 2 plus 9 minus 3h minus 11 upon h. And therefore limit h tends to 0. Therefore minus 3h upon h. That is equals to minus 3. And right hand side limit is minus 3. Left hand side limit is not equal to the right hand side limit, and hence the f is not differentiable at x is equals to minus 3. Show that f of x is equals to x square is continuous and differentiable at x is equals to 0. One thing is that f of x is equals to x square. This is the polynomial function, and the polynomial function is always continuous and differentiable. Therefore, we'll take the right hand side limit. That is limit h tends to 0. F of 0 plus h minus f of 0 upon h. That is f of 0 plus h. That is the function f of x is equals to x square. Therefore, f of h square minus 0 upon h. Now h will get cancelled, and its limit is 0. Left hand side limit f dash of 0. Limit h tends to 0 minus f of 0 plus h minus f of 0 upon h. That is limit h tends to 0. H square minus 0 upon h. H tends to 0. H upon h. And overall, that you will get its limit is left hand side limit is 0. Therefore, right hand side limit and left hand side limit both are equal. Therefore, f is a differential at x is equals to 0, and hence it is a continuous at x is equals to 0. Now next is right hand side differentiation. Discuss the continuity and the differentiability f of x is equals to x mod of x at x is equals to 0. That is f of x is equals to x square if x is greater than or equal to 0. f of x is equals to minus x square if x is negative. Now first of all, here we have the mod of x, and this mod of x is positive, is plus. Mod of x is equals to x if x is positive. It means that x is greater than or equal to 0. Now I am writing here, that is this is important. That is f of x is equals to x square. This is x, and mod of x is, we have treated here as x because x is greater than or equal to 0. And this f of x is equals to minus x square if x is a negative. At that time, the value of the mod of x is minus x. Therefore, minus x, and therefore the right hand side differentiation, that is, or you may take it's a limit or differentiation, it doesn't matter. That is a limit h tends to 0 plus f of x, 0 plus h minus f of 0 upon h tends to 0, h square minus 0, and overall it is a 0. This way. Now the left hand side differentiation, or the left hand side limit h tends to 0, f of 0 plus h minus f of 0 upon h, limit h tends to 0 minus h square, because we have defined the first, its a value is a minus h square, and overall you will get its limit is 0. Therefore left hand side, right hand side both are same, and hence it is a differentiable at x is equals to 0. F is a differentiable at x is equals to 0. And hence continuous. Because by using the converse we are proving this. Now the f of x is equals to 2x plus 3 mod of 2x plus 3 at x is equals to minus 3 by 2. If x is greater than or equal to minus 3 by 2, then the mod of 2x plus 3 is equals to 2x plus 3. Therefore, if x is less than minus 3 by 2, then mod of 2x plus 3, that is equals to minus 2x plus 3. This is important. Therefore, f of x is equals to 2x plus 3 mod of 2x plus 3. Then you will get 2x plus 3 bracket square when x is greater than or equal to 0. Now see this, greater than or equal to, sorry, minus 3 by 2. Okay, and is equals to minus 2x plus 3 bracket square for x is less than minus 3 by 2. Therefore, the right hand side differentiation, left hand side differentiation, it is nothing but the left hand side, right hand side limit. Therefore, limit h tends to 0. We will take the function for the, there's a plus sign for the function upon h. Their simplification, you can write this. Limit h tends to 0 for upon h therefore you will get the limit as 0. Similarly, left hand side differentiation, that is a minus 3 by 2, limit h tends to 0, f of minus 3 by 2 plus h minus f of 3 by 2 upon h, limit h tends to 0, minus in bracket 2 in bracket minus 3 by 2 plus h plus 3 brackets square minus in bracket minus 2 in bracket minus 3 by 2 plus 3 brackets square upon h, and after simplification you will get from this bracket. If you multiply it by 2, then minus 3 2h plus 3 bracket square minus, in the next bracket your simplification is like this, minus 3 plus 3, therefore that is a minus 2h bracket square plus 0 upon h. Limit h tends to 0, minus 4h square, that h get cancelled, that is a minus 4, that is a 4h, that is equals to 0. Left hand side differentiation, right hand side differentiation, that is equals to, both are the same thing. Therefore the f is a differentiable at x is equals to minus 3 by 2, and hence is a continuous at x is equals to minus 3 by 2. Now next discuss the continuity and the differentiability f of x at x is equals to 2 if x belongs to the closed 0 and 4 open, and that square bracket indicates the greatest integer, that is a floor function. Okay. Now here we'll write the function f of x is equals to greatest integer function if x belongs to 0 close 4 open, f of x is equals to 0 0 to 1. Now see this function how it has been defined. 0 is included, 1 is not included, 1 is included, 2 is not included. Now this is the greatest integer function. Which is the greatest here? 0 is the greatest. Which is the greatest? 1. In this way we will get to see. Therefore f of 2 is equals to 2 at x is equals to 2. Left hand side limit, right hand side limit. Then the left hand side limit you will get 1, right hand side limit you will get 2. For the right hand side limit you will get 2. You will see that continuity, in the continuity I had also explained this type. That is 1 is not equals to 2, and therefore left hand side limit is not equals to the right hand side limit. Therefore the limit does not exist, and hence the given function is not continuous at x is equals to 2. At x is equals to 2. Again, the given function is not a differentiable at x is equals to 2. If it is continuous, then it is a differentiable. Next, suppose it is a differentiable at x is equals to 2. Then it must be the continuous. Then if it is a continuous at x is equals to 2. But we have proved that limit does not exist, and hence it is not continuous at x is equals to 2. Hence f is neither continuous nor differentiable. These are difficult questions. That is a question number 7. Test the continuity and differentiability of f of x is equals to 3x plus 2 if x is greater than 2 and equals to 12 minus x square if it is less x is less than or equal to 2 at x is equals to 2. Now the continuity at x is equals to 2. Limit x tends to 2, left hand side limit. That is it. We'll take the function 12 minus x square. That is equals to 8. Right hand side limit. For that we'll take the function 3x plus 2. Its answer is again 8. Left hand side limit is equals to the right hand side limit. The given function is a continuous. Limit exists and it is a continuous at x is equals to 2. Now about the differentiability. F of x is equals to 12 minus x square if x is less than or equal to 2. Left hand side differentiation, that is the limit x tends to 2 minus f of 2 plus h minus f of 2 upon h minus, now see this, the function 12 minus x square, that is a 2 plus h bracket square minus 12 minus 2 square. Limit h tends to 0. 12 minus, that is a in bracket 4 plus 4h plus h square minus 8 upon, that is the limit h tends to 0. 12 minus, if you open the bracket, then you will get the terms like this. That is minus 4h and minus h square upon h. If you take h as common, then you will get limit as minus 4. Now the left hand side, this is the left hand side differentiation, that is r f dash पाहिजे तिथे. I forget to write the dash. That is the right hand side differentiation, that is the right hand side limit. We can take it as therefore 3h upon h, that is limit h tends to 0, you will get the constant, that is equals to 3. Therefore left hand side, that is f dash of f dash पाहिजे मात्र तिथे. Now from 1 and 2 both are not equal, there must be the dash. I forget to write down it. F is a not differentiable at x is equals to 2. It is not continuous. Now if f of x is equals to sine x minus cos x, if x is less than or equal to pi by 2, and 2x minus 5 plus 1 if x is greater than pi by 2. Test the continuity and differentiability. Now check its continuity at x is equals to pi by 2. Now we'll find out its left hand side limit and right hand side limit. F of x is equals to sine x minus cos x if x is less than or equal to pi by 2. And 2x minus 5 plus 1 if x is greater than pi by 2. Now the left hand side limit. F of x is equals to, this is the limit x tends to pi by 2, f of x, limit x tends to pi by 2, that is the left hand side limit, sine x minus cos x. If we substitute the values, that is a pi by 2, then you will get 1 minus 0. Sine 90 is 0, sine 90 is 1, cos of 90 is 0, that is equals to 1. Therefore, the left hand side limit is 1. What about the right hand side limit? That is a solid. And after simplification, you will get 2 into pi by 2 minus 5 plus 1. Plus 5 minus 5 get cancelled and you will get 1. and that's why limit x tends to pi by 2 plus, that is the right hand side limit is 1. From 1 and 2. Therefore f is, both are equal, therefore f is continuous at x is equals to 2. X is equal to pi by 2. Now differentiability at x is equals to pi by 2. Of x is equals to sine x minus cos x. Their values, left hand side f dash of pi by 2. Limit h tends to 0 minus, that is the left hand side, pi by 2 plus h minus f of pi by 2. After substituting the values, minus 1 upon h, limit h tends to 0. Now here we will simplify, that is sine of h upon h, cos of h minus 1 upon h, limit h tends to 0, sine of h upon h, take minus n common, 1 minus cos h upon h. Therefore the value of, now to simplify this limit 1 minus cos h upon h, multiplied numerator denominator by 1 plus cos h. To simplify this, limit h tends to 0, that is 1 minus cos square h upon 1 plus cos h, that is sin h upon h, sin square h upon h square, adjust h, 1 plus, that is a 1 minus, and overall we will get 1. That is the left hand side differentiation, that is equals to 1. Now right hand side differentiation, that is at x is equals to pi by 2. By using the first principle, this is the right hand side differentiation. After the substitution, you will get, that is a 2h upon h, that is equals to 2. Listen to. Therefore from 1 and 2, 3 and 4, that is both are not equal, therefore the given function is not differentiable. Therefore at x is equals to pi by 2. Examine the function f of x is equals to x square cos of 1 upon x for x is not equals to 0, equals to 0 for x is equals to 0. For the continuity and the differentiability at x is equals to 0. Now the continuity at x is equals to 0, the given function is, it's a clear, value is 0, its limit is also 0. F of x is equals to limit, that is the limit h tends to 0, f of x is equals to limit x tends to 0 x square cos of 1 upon x, that is 0 into cos of, the values lie between, finite values lie between minus 1 and plus 1 always. The cos of 1 upon x as x tends to 0. Therefore 0 into whatever that value is, it becomes 0. Therefore so value is 0, limit is 0, therefore the given function is continuous at x is equal to 0. Now the differentiability at x is equal to 0, f dash of 0, limit h tends to 0, f of 0 plus h minus f of 0 upon h, limit h tends to 0. Therefore, h square cos of 1 upon h minus 0 upon h, that is limit h tends to 0, h into cos of 1 upon h. Overall, as h tends to 0, this overall is become 0. Therefore, f dash of 0 exists, and hence it is a differential. In this way, we have completed this exercise, that is a 9.1. That is r of f dash of x. When we treat is, that is a differentiability for the right hand side. L of f dash of x, that is sometimes it is treated as the left hand side differentiation, right hand side differentiation, but sometimes by the mistake I had treated as left hand side or right hand side limit. Okay, now we'll see in the next video. Till then, goodbye.